I'm Eliane Wiese, and I am presenting Students' Misunderstanding of the Order of Evaluation in Conjoined Conditions. This is work that I did with my collaborator Anna Rafferty at Carleton College and my amazing undergrad student, Garrett Moseke. The big question in this line of work is, how can we help students code with better structure? Better meaning that it's easier for others to read and maintain. Sometimes that's subjective, so better also means what professionals and instructors prefer. Two questions that go along with this work are, where do students need improvement? And, by focusing on code structure, what can we learn about students' code comprehension? This study looks at two different factors in checking conditions. So, one, a novice structure is to separate each condition into its own if statement, while an expert structure is to conjoin statements, for example, by using logical and. Second is how conditions are ordered. An incorrect ordering might do something like try to access a value at a certain index without checking that the index is in range, whereas the correct ordering would first make sure that the index is valid. This study examines intermediate students' misconceptions, finding that when intermediate students write code, they often conjoin the conditions using logical and, but they're less likely to do so if they have an error check condition, which they're more likely to separate out into its own if statement. Also, when they write, they usually put the error check first, but comprehension questions reveal that they don't always recognize why that ordering avoids errors. And these misconceptions are revealed by examining the structure of students' code. So we find that intermediate students don't always recognize how conditional ordering affects execution, but it's easier for them to recognize the importance of ordering when the conditions are in separate if statements rather than conjoined into one if statement. We ran this study by deploying an assessment to students in two computer science classes, a third semester class in software engineering and a second semester class in data structures and algorithms. Students did this survey at the end of the semester. It only included an assessment, not instruction. Tasks included writing code, comprehension questions, and revising the code that they had written if it was flagged. In the writing task, students are asked to check if the quotient of two inputs is 5 or larger, and if the first input is bigger than 10. In doing so, students are also given a hint to avoid an exception caused by dividing by 0. To accomplish this task, students are provided the method signature and the closing brace. One way to do this is to have one condition check, is the first input divided by the second 5 or larger, and a second condition to check if the first input is bigger than 10. The hint reminds the student to avoid an exception caused by dividing by 0. That condition needs to go first. In analyzing student responses, we find that expert structure is rare because students often isolate the error check. So first, only 54% of students included a check for 0 at all, even though it was explicitly directed in the hints. A minority of students, 14%, checked all conditions in one if statement using expert structure, and 29% of students isolated the 0 check into its own if statement. So notably, even students who isolated the 0 check were still using the logical and to conjoin the other two conditions. So the problem wasn't that they couldn't conjoin conditions at all, just that they chose to isolate the 0 check into its own if statement. We also found that when students did check for 0 and had division, they overwhelmingly did so in the right order. So of the 63 students who included a check for 0 and included division, 62 of them, all but one, did it in the correct order. Our comprehension questions looked at the ordering of conditions and the code structure. We found that students often missed the importance of order. We found this by presenting code samples that examined a character at a certain position in a string and compared that character to an inputted one. In one code sample, the condition that checks the target character comes before a check to see if the position is valid. Another version of the code has the conditions in the correct ordering. A third and fourth version of this code have the two orderings, but this time all conditions are conjoined in one if statement. Each student saw all four code samples and answered the same comprehension questions about them. 1. Does the code accomplish the desired task? That is, does it return the letter at the target position if it's larger than the inputted letter? And 2. What is returned for a specific input where the position is out of range? We found that students did pretty well when the conditions were in the right order, although they did better when the conditions were separated into individual if statements. But when the conditions were in the wrong order, a lot of students didn't notice, and students were much less likely to be correct, especially if the conditions were conjoined in one if statement. This held overall for when the code accomplishes the task and for asking about a particular input. Overall, this shows that students who write code correctly don't always understand what factors make it correct. Students rarely misordered conditions when they wrote, but frequently misunderstood what would happen when code did use incorrect ordering. Students may put error checks first because they find it more readable, not because they understand how errors can interrupt code execution. Examining code structure revealed nuances in students' understanding of code execution, showing that focusing on structure is an avenue for assessing comprehension. We also show that examining comprehension versus writing illuminates different facets of understanding. There is more in the paper, including how students revise their code, how this relates to theories of learning, and statistical analysis. Thanks so much. I look forward to your questions.
Let's start with some questions. One about Alexander. Can you conjecture why the students miss importance of the order of conditions? Please, Eliane.
Thank you. Great question. This is something that I'm starting to look at more carefully now with asking students when they think different conditions execute. And what I'm finding is that some students actually think that most execute at the same time. So I think that because especially when the conditions are all conjoined on one line, students may forget that the computer can only execute one thing at a time. So that I think is part of it. And another could be that if they don't have experience looking at code where the order of conditions would cause errors, then they're not attuned to thinking that that's a problem that they should watch out for.
Thanks, Eliane. We have another question from the audience, from Karian. Did you try to compare the two groups of students from the different classes? Were there any differences if you did, of course?
I didn't do that with this sample because it was so skewed heavily towards one class, but that's something that I would love to do in future work.
Yes, indeed, very good answer. Another answer from Venera. So thanks for the presentation, great work. I mean, I agree. Question, what do you suggest that we as an instructor do to increase students' understanding of the order of evaluations?
I don't have an empirical answer to that yet, but my hunch is maybe giving students problems where the order of evaluation matters and leads to a different result, and show students code where one ordering causes errors or leads to a different kind of calculation so that they have experience thinking through code tracing of what happens with different orders, and especially giving them practice with thinking through what happens when an error causes execution to stop and how that can affect the program.
Okay, great. Thanks, Eliane. Last question, we have 30 seconds. Is this because e-commercial, double e-commercial is symmetric in logic and not symmetric in CS? I don't think that you have enough time to answer because we have 50 seconds. So I will suggest you to go on the chat and type there the answer. So, okay, I'm alone now. So, okay, let's start with another presentation.